Okay, guys, we're going to talk about oxidation reduction reactions, which is section 4.4 in your book. So an oxidation reduction reaction is a reaction where electrons are transferred during the reaction. So remember the law of conservation of mass, we have to have everything that we start with at the end of our reaction. So in this type of reaction, we are moving electrons, and the thing being oxidized is going to lose electrons, and the thing being reduced is going to gain electrons. So the oxidation occurs when we lose. So we can remember that by the word oil. Oil is oxidation, is loss. And when you lose negative electrons, remember you're going to become more positive. And then reduction is gain of electrons. And when you gain negative electrons, you're going to become more negative in your charge. So to decide if it's an oxidation reduction reaction and then what is being oxidized and what's being reduced, we need to analyze an equation and kind of figure out what the charge of each part of it is. So we're going to go over some of the rules for assigning oxidation numbers. It's slightly different than our cation anion charges. So just keep in mind, we want to follow these rules. So to determine if an oxidation reduction reaction has occurred, we're going to give it this oxidation number. So remember, a compound is neutral. So we've balanced the number of electrons. And so we need to keep that in mind. When we do an oxidation reduction reaction, each of the compounds in the reaction have to be neutral. So atoms in their elemental form have the oxidation number of 0. This includes diatomics. So if you have something like chlorine gas in a reaction, that's going to have an oxidation number of 0. If you have something like solid copper, like in our copper lab, that's going to have an oxidation number of 0. There's nothing else to balance it out, so it has to be 0. The oxidation of a monatomic ion is its charge. So if we look at something like sodium chloride, we've got one cation, one anion. The only thing that they can be is their charges that we've talked about. So chlorine is going to be -1 and sodium is going to be +1. A couple of things just in general. Metals tend to have a positive oxidation number, just like their cations, when we are making our ionic equations. And nonmetals tend to have negative oxidation numbers, just like we've been seeing throughout the year. The fifth rule is that oxygen almost always has an oxidation number of -2. Really, the only exception to this that we're going to see is in hydrogen peroxide, H2O2. Here, each oxygen has a -1 value. Almost every other situation, though, oxygen is going to have a -2. Hydrogen can have an oxidation number of +1 if it's with a nonmetal and it's acting as the metal, or it can have a -1 if it's with a metal and acting kind of as the nonmetal. So we have to look at the situation we're in for hydrogen. And then fluorine always has an oxidation number of -1. So keep these rules handy as we're going to do some practice. When we're assigning oxidation numbers, you want to start with kind of the always rules, so oxygen, hydrogen, fluorine if there is one, and then you can work out and balance from there. So the sum of the oxidation numbers in a neutral compound is 0. And so if it has an ion charge, we have to take that into consideration. We have to leave that charge. So let's look at a couple of these. So if we're looking at NH3, we have 3 hydrogen and 1 nitrogen. So hydrogen is one of our always rules. It's always going to be either +1 or -1. Since hydrogen is with a nonmetal in this one, it's going to be +1. So each hydrogen is +1. I like to write the oxidation numbers kind of up above, but I have 3 of those hydrogens. So overall, hydrogen is a +3. So I need to balance that out with my nitrogen because this is a neutral compound. So if each hydrogen is +1 and I've got 3 of them, I have a charge of +3. So nitrogen has to be a charge of -3 in order to balance that out. So I would say that in this compound, nitrogen has an oxidation of -3, and each hydrogen has an oxidation number of +1. Okay, let's go to the next one. So if we look at H2SO4, remember we have rules about hydrogen and we have rules about oxygen. So in this scenario, hydrogen is with SO4, which is a polyatomic ion, and it's an anion, an overall negative charge. So that means we want our hydrogen to be positive. So each hydrogen is going to be a +1, but I have 2 total. So I have a +2 charge so far. My oxygen is always -2 unless it's hydrogen peroxide. This isn't hydrogen peroxide. So I have -2, but I have 4 oxygens. So that means I have a -8 overall. Now, if I want this to balance, I need to add those numbers up to 0. So my hydrogen equals a +2. My oxygen is -8. So that means my sulfur has to be a +6 to balance it out. Now, I couldn't have known that without doing my hydrogen and oxygen first. So make sure you start with the things that are for sure, and then you can go from there. Na is just solid sodium. There's nothing to balance it out, so it has to be neutral. Same thing with chlorine. It's chlorine gas. There's nothing else to balance it out, so it has to be 0. Okay, pause the video and try ZnSO3 on your own. Hopefully you actually paused it. Let's go ahead and look at that. So Zn is going to be its charge that it always is. So that's going to go back to that rule number 2. The oxidation of a monatomic ion is its charge. So zinc is always a +2. So we'll give it its +2 charge. Oxygen in this situation is -2 because it's not hydrogen peroxide, but I have 3 of them, so that gives me a -6 charge. So in this case, my sulfur, in order to balance it out, is going to have to be a +4. So we can see that that's different than it was in H2SO4. So the oxidation number can change. Unlike the charges that we've been using to put together our ionic equations. Okay. Let's look at that other sulfur one. So SO2, pause the video, try it, and then check your answer. Hopefully you paused it and you realize that each oxygen is -2, so that's a -4 total, which means that this sulfur is also a +4. Only other different thing could be if we have, like with this ClO4 minus, an extra electron in that. It's an ion. So we need to take that into consideration when we're balancing. So our ClO oxygen here, -2 apiece for a total of -8. And we need to keep one of those negatives. So that means that our chlorine has to be a +7. Okay, go ahead and try our last one here, our aluminum hydroxide. Okay, aluminum is a monatomic ion, so that's going to be +3 like it always is. Our hydrogen and oxygen. Oxygen has to be -2. So that means our hydrogen's with the nonmetal. That means our hydrogen is going to be a positive. So let's look at that. So that's a +1. So we've got 3 hydrogen, so that's a +3 overall. We have 3 oxygen, that's a -6. And then our aluminum +3, this one cancels out and becomes neutral as well. So once you feel comfortable being able to identify those charges, then we need to put it into practice with an equation. So